let me use a notepad to finish it faster. Let me also run OSPF IP OSPF 1 area 0 IP OSPF 1 area 0. So we got IP address and OSPF. This will be on router 1. Let's paste this on router 1. Likewise on router 2, F00 is going to have 10.62. 62.6. I always use the router name as the host ID. So .6. That's all. Copy and paste this on router 2. Oh yeah, thank you. This router 2. Done. Next is, let's finish router 6. F00 will have .6 here, and F0, sorry, G3/0 G3/0 is going to have 56.6. Router 6. Alright, on router 5, Lubbock is going to have, and G0, G4 slash G3 slash, no, let's put 4 slash. 4/0 will have 56.5, and 3/0 will have 45.5. Yeah. All right. Okay, so we have done router 5. Another 2 routers. Router 4/0 is 45.4, and 3/0 is 34.4. And this is 4. This will be on router 4. Now what I'm going to do now, I'm not going to run OSPF on router 3's loopback. See what happens. 3.3.3.3. What is this? 1 minute. Every time this works, remove my plugs and pad. Now, see, we don't have OSPF here, and on 3/0, it is going to be 34.3. That has got OSPF, and F0 will have 13.3. This is on router 3. Okay, so we got OSPF. According to me, we have done it correctly, so I should be pinging from router 1 to router 2. Ping to that 2 with the source 11111. If this ping happens, OSPF is good. So we don't have any problem in IP address or in OSPF. Whatever configured so far is good. As I said earlier, we don't have OSPF running on loopback R3 show IP OSPF interface brief. See, it's not running. Also on R4, I'm going to remove OSPF from the loopback. So both on R4 and R3, there is no OSPF. Show IP OSPF neighbor. I got neighbor, show IP OSPF interface brief. There is no OSPF on loopback. There is no OSPF on loopback. The reason why I did this is I told you yesterday, LDP uses TCP. And using the router ID, they will negotiate. When I enable MPLS, like OSPF, MPLS will also use the loopback interface as a router ID. And if the router IDs are not reachable, MPLS cannot do three-way handshake. So LDP neighborship cannot come up. It won't come up. Okay, so if you see here, show IP protocol, router ID is 4444, even though we don't run OSPF on that interface. Likewise, when I enable MPLS, 4444 is going to become a router ID of MPLS, with which MPLS will try to negotiate. To show that, I would like to sniff a packet between these two. Now, these are all OSPF packets. You can see OSPF here. 224005 OSPF will use, whereas LDP is going to use 224002. Let's enable MPLS on R3. Enabling MPLS is very simple. MPLS IP, that's all. This is on the global mode to start the MPLS process. If this command is taken, then this becomes a LSR, label switch router. But we have to specify on which interface that you want to run MPLS. And G. Same command MPLS IP. Now, if you see, there is a LDP packet going immediately from router 3 to 224002. And you see the LSR ID is 333. It is this LSR ID which should be reachable from the router, whoever receives this packet. See, this is sent to this multicast address 224.0.0.2. 224.0.0.2 is a routed multicast address, meaning every router in the next hop can receive it. You see the port number 646. Okay, and the TTL is only one for routed mode multicast 224.0.0.2. Initially, it will use UDP 17. Later, it will switch to TCP once the three-way handshake is over. You see, initially it will use user datagram protocol 646 UDP. All right, but later after the neighborship, it becomes TCP after three-way handshake. Currently, the LSR ID is 333, going from router 3. Likewise, on router 4, I'm going to say interface G3/0 MPLS IP. Now, again, you will see from router 4 also I'm getting an LDP packet, and the router ID, the LSR ID is 444. Now, router 4 do not know 333. I can show you that router 4 ping 3.3.3.3. Oh, sorry. The reason is we don't run OSPF on loopback of R3. So neighborship will never come. Though I have enabled MPLS, show MPLS LDP neighbor, you don't see any neighbor. Right, all the LDP packets are still UDP, user datagram protocol. But as soon as I enable interface loopback 0 IP OSPF 1 area 0, after I enable, the OSPF update goes with the new network. And now you see LDP hello messages are reaching successfully, and you see three-way handshake is trying to happen, but the three-way handshake will not complete. Why? Only on one side we have enabled OSPF on loopback. So you have to enable on either side for three-way handshake to get completed. Interface loopback 0, IP OSPF 1 area 0. Now if you see three-way handshake will happen. Wonderful. See the three-way handshake, you can see now LDP messages are shared. Fine. Now if you capture one LDP packet, you will see TCP in place. Still LDP. Let's go to the command line and check. Okay, neighbor has come. I can see here the neighbor. Show MPLS LDP neighbor. You see this TCP connection, TCP 646. Now the neighborship is initiated from router 4. That's why the random port number. Router 4 has initiated the neighborship. Router 3 has responded to it. The one with the bigger router ID only will initiate. Router 3's router ID is 333, 444. Router 4 is bigger than router 3, so router 3 has initiated. So router 4 has initiated and router 3 has responded. You can also see that in router 3. Show MPLS LDP neighbor. Even here the same information. Router 4 has initiated and router 3 has responded. Next. Yep. They are initiated. Correct. LDP's port number is 646. That is what. No, the hello packets went in between them, and and router 3 understood that I cannot initiate because router 4's router ID is bigger than mine, and router 4 understands that I have to initiate. The hello packets helps them to understand who will be the designated router to do this. Yep. So it is actually TCP now. But here it shows us LDP, but it is already TCP. The hello messages will be UDP, but the other transactions updates between the LDPs are going to be TCP only. So let me try to filter out LDP. Okay, I see only the LDP packet. Let me stop the capture and go to the top where the first three-way handshake 4 also. Okay, here is the 4. 4. This is the first time 4 has responded. And this is hello message. Okay, here is the three-way handshake. Keep alive initialization message. See, it is 3 TCP. Other than hello packets, all other LDP packets are TCP based. It's not UDP here. Here it is TCP. Initialization happened from source to the destination 3333. The source port number was random. It's the same port number that you saw there in the, you see, 30138. 30138. And then the response from router 3, right? All these are TCP. Okay. All right. So that is what we need to check. Now let me close this. So we learned one big reason why I have to run OSPF on loopback interface. If not, they cannot form neighbor because the label switch router's ID must be a reachable address to form neighbor. Router 3 and router 4 is over. Let's finish router 5 now. Now, even in router 4, I have not configured MPLS on G4/0. I can verify by typing this command show MPLS LDP, show MPLS interfaces. You see here, MPLS is running only on G3/0. There is no need to run MPLS on loopback. If you try enabling in loopback interface, it won't accept. Because in loopback interface, LDP distribution cannot happen. No, see, let me try doing it. Interface loopback 0 MPLS IP. You see, MPLS is not supported on the loopback interface because LDP cannot do any distribution over there. Now interface G4/0 MPLS IP. Done. Likewise, I have to do that similar configuration on R5. MPLS IP interface range G3/0, G4/0 MPLS IP. And on R6, MPLS IP interface G3/0 0 only. I'm not going to run MPLS on customer facing interface. You should not do that. So only on G3/0. Now the neighborship has come. Even here, if you verify show MPLS LDP neighbor, you will see 6.6.6.6 as initiated. So when I initiate, I no need to say LDP. When I talk to someone only, I should say LDP. So initiator will have some random number and go to router 5 and say, I need LDP. So 646 means router understands that you are looking for LDP neighborship. Now, so the destination port number is important. For the one who initiates, the destination port number should be matching with the service. For example, if I'm doing telnet, my source port number will be random number and the destination port number should be 23. Now, yes, question. Mhm. Same like OSPF, it'll take the biggest IP address from the physical interface. But the problem is that's a poor design. You should have loopback if you're running MPLS. That's the good practice. Okay, so far we have finished the basic configurations. We have seen neighborship coming up, all those things. Now next is I want to show you the labels. Before that, I want to disable MPLS on one of the router because I should have shown you Ceph table before MPLS. So no MPLS IP. Show IP Ceph. You see, this is how the Ceph table looks like. For example, to go to the route 6.6.6.6, you need to go to this gateway. This is the IP address of router 6. I'm showing this output from router 5. Router 5 says in order to go here, I need to go to this gateway, and this is the exit interface. You see, you don't need a routing table now. Show IP route 6.6.6.6. Even the routing table says the same thing. You see, go via G4/0 and go to this gateway. Why do I need routing table now when I have Ceph table? You see, Ceph table is built by using routing table. For that I need. But when a packet arrives, I'm not going to look into this routing table because the Ceph table show IP Ceph for 6.6.6.6. It shows the same info in a very simplified way in a layer 2 level. Yeah. Now, when I enable MPLS, see what happens. MPLS IP. And now the same Ceph table I'm going to show you. Show IP Ceph for 6.6.6.6. You will soon see a label here. Okay. I need to teach you one more thing called PHP. That's why you are not seeing label here in router 5, but in R4 you will see a label. Before that, in R4, let me enable disable MPLS. No MPLS IP. You see, show IP Ceph 6.6.6.6. See, there is no label. But now, when I enable MPLS, you will definitely 100% see a label. There is another reason why router 5 did not have a label, which I need to explain you. But in R4, if you see, you got a label. Earlier, when I showed you the Ceph table, the label was not there. And now, you know whose label is this? This is the label of R5 to reach 6.6.6.6. Let me show you on R5. Show MPLS LDP binding for 6.6.6.6 32. You see the local label is 28. That is what you see here. Router 4 will use the label given by router 6, not the label given by router 4. If you check router 4, show MPLS LDP binding for 6.6.6.6 32. See, this is the label given by R5, and this is the label given by R3. It is not using label given by R3 because R3 is not the path. R5 is the path. R5 is the direction downstream. So it puts the label given by R5. And you know, I told you, even if your label and your neighbor label is same, it is okay. If you check this command, show MPLS forwarding table for 6.6.6.6. In this router, you will see both local and outgoing label is same for this network. It doesn't mean that they're going to conflict. They will not conflict. If two routers generate the same label for a network, it is okay. That will not cause any problem. If you want different label, then you need to shuffle MPLS IP, just cancel once, and then put MPLS IP. When you do this, what happens? Router 4 will not use the same label what R5 uses. Now if you check, the local label is different. Now this is the label of R4 which will be used by R3. If you go to R3 and check, show MPLS forwarding for 6.6.6.6, you see the outgoing label is 36. This is the label of R4. Here outgoing label of R4 is 28, which means the local label of R5 is 28. Go to R5 and check. You see 28 is the local label. Now why R6 is having implicit null? Meaning R6 have advertised a label, but the label cannot be seen. Why? We call it as PHP, penultimate hop popping. I'll teach you what it is in a few minutes, but before that I want to explain you. This implicit null means there is no label to be attached while sending this packet to router 6. That's the meaning. R5 is very clear that I should not add any label before sending it to router 6. You see, show MPLS forwarding table. For 6.6.6.6, it says I'm not going to put any label before sending to R6. I'm going to pop the label. Why is this popping the label? Is what we are going to learn next. But before going into that next topic, I would like to trace route and show you that now the labels will be involved in packet switching. Trace route. You see the labels are involved in switching the packet. And now I will. Okay, Wireshark, I have closed it already. It's okay, we'll see the other day, another time with the Wireshark. Now, labels are involved here. And what I understand from here is R4 receives a packet with the label 33. R4 receives a packet with label 33, which means R3's outgoing label is 33. R3's outgoing label. Let's check. Show MPLS forwarding for 2.2. That is the destination we are tracing. Yeah, see, outgoing label is 33. That is why I see R4 has received the packet with the label 33. Yeah, which means R4's local label is 33. And R4's outgoing label is 25. And R5's local label is 25. Let's go and check R5. Local label should be 25. For 2.2.2.2, yes, 25. And the outgoing label is 17, which means router 6 label. Router 6 label is 17. Let's go and check router 6. Show MPLS forwarding for 2.2.2.2. Yeah, it's 17. And router 6, when it is trying to send it to router 2, it is not popping the label. It says no label. Why? Because we don't have MPLS running between router 6 and router 2. There is no MPLS, so it says I don't have any label, so I'm going to do what? Normal IP routing. It has done normal IP routing. Okay, now what is next? When I was tracing the route, okay, let me trace route one more time. I don't think I have traced the route to 6666. When I trace the route for 6.6.6.6, you see, when packet received on R6, it did not receive any label. The reason is the R5 has popped the MPLS header. R5 has popped the MPLS header. There is no MPLS. When the packet is received on R6, it is received as IP packet only. It is received as IP packet. Why R5 pop the label? We call it as PHP, penultimate hop popping. That will always happen on the n-1th router. Now, you see, packet arrives, the destination 66666. This is going to provide a label. What label it gave? It has given label number 36. It has given label number 36, which is the local label of R4 for 6.6.6.6. And now R4 received the packet and put the label number 28, because that's the label of R5. So R4, what it does, it swaps the label. Here the push operation happened, pushing of label or label import. And here swap. 36 is swapped with 28. And the packet goes here. And this router R5, so why R5 did not give any label before sending to R6? It was sending as normal IP packet. Why? Why should R5 pop the label? Because if you check the R5's LFIB table, this is what LFIB table, label forwarding information base. It says I will not put any label, I will just pop the MPLS header. I'll send it without any MPLS header. Why should this done by default? Now you see, if in case it received with a label, now to deliver the packet to the interface here, there is no label given in the loopback interface. There is no label advertised in this direction. This is just connected interface. It is just connected interface. So it has to now depend on the local routing table or local adjacency table to deliver. There is no more label possible because it is directly connected wire. Loopback is also a directly connected, of course it is. So if you notice that 10.64 also there won't be label. So 10.62, you see. Router 5 is popping the label for 10.62 as well as 6.6 because it is the connected network for router 6. If my very next router has got some network connected, for those networks I have to do popping. If I send with the label, it has to do MPLS lookup and then it has to do the IP lookup to deliver the packet. So two lookups you need to do. To avoid that two lookup, if I simply pop the MPLS header and send, it will do only one lookup, which is an IP lookup. That is why we need PHP, and the PHP is enabled by default. PHP is enabled by default. Yeah. So that's about PHP. Even if you see in R5, the R4 directly connected networks are PHP. You see, R4 is 10.34 will be PHP because it's very next routers directly connected. Penultimate hop popping. Before sending the packet to the ultimate destination, it will pop the label to avoid MPLS lookup and to avoid MPLS lookup. Because in order to deliver on the physical interface or loopback interface, which is directly connected, you need the support of the adjacency table, not the MPLS table. So there is no point of having a labeled packet between R5 and R6 when R6 is the final destination. But for R2, if you notice, for R2, it is not having a pop, it is having a label. After reaching R6, R6 finds no label. Then it does again route lookup and then it sends out. Here, there is two lookup done on R6 in order to go to 2.2.2.2. Two lookups. It comes with a label. And R6 now tries to check label to reach 2222. But there is no label. So it looks into the routing table. And then it understands I need to send it via F00. Not only routing table, even Ceph table, you see. Ceph table will not have any label. Show IP Ceph for 2.2.2.2. There is no label. So it uses the gateway and the exit interface to send the packet out. To avoid such lookup twice, we have PHP. But PHP is done only for those MPLS routers. See, R2 is not an MPLS router, so no PHP for R2. Penultimate hop popping. Any question? Any question on PHP? Any question on how the labels are used? How the labels are used in packet forwarding? Any question on how the labels are used in packet forwarding? Do you have any question?
But I have a small question. You are referring to adjacency table, right? So just like a routing table, we have to look at a routing table to show IP routing. So is there any command to say adjacency?
See, based on what you see here as an exit interface, it will use this interface MAC address and this IP address ARP will give the destination MAC address. That is what we call as adjacency table. The table that that is referred to provide the exit interface MAC address and the next hop's MAC address. Okay, the exit interface MAC address is taken from the interface itself, F00, and the next hop is show IP ARP. There it shows the destination MAC address. This is what adjacency table here means. layer to adjacency table. Right. So